Hey there, rock stars, and welcome to another episode of Rock Talk. Today, I wanted to start talking about scientific articles. It's a great way to kind of jump into cutting edge research in terms of cool discoveries in the geosciences, what actual scientists are doing. But it's also an excellent opportunity to talk about how the media portrays science and scientific discoveries as well. And today I would like to kind of cut into one of those press releases about a cutting edge research into the science with this article that was just recently posted, titled "Mysterious Underground Continents May Be as Old as Earth." And that is quite a clickbaity title. It has a lot going there, a lot of mystery, a lot of what's going on there? Like, how could there be continents as old as the Earth inside the Earth? You know, it doesn't sound like there's really too much credence to it. So I wanted to look up the original article, go through the original article and the actual article's findings, and kind of see, is this clickbait or is this legitimate scientific journalism? Let's find out on this episode of Rock Talk. Before we just kind of jump in there and start talking about the article, I wanted to kind of give a little bit of background just into the interior of the Earth in general and what we as geologists, as scientists, as human beings kind of have as the general accepted knowledge as to what's in the Earth, what's underneath the surface here on the planet, because that will be very important to our discussion today. So far as modern science is concerned, the interior of the Earth is organized into different layers based off of the general geophysical properties that reside there. The topmost thin little crust around the Earth is what we live on, and it's called the crust. You guessed it. The topmost portion, and only goes down a very short amount. It's only goes down about 35 kilometers deep. At the thickest, that's thick continental crust. Oceanic crust is only about 6 kilometers thick, which is wild because that seems like an awful lot. That's a really, really, really thick portion of the Earth, but compared to the entire size of the planet, it's actually not that much at all. Get through the crust and now you are in the mantle. And the mantle is actually subdivided in a couple of other layers as well. The upper mantle is composed of two separate sections, the asthenosphere and the lithosphere. The lithosphere is kind of a boundary between the mantle and the crust there up top. Beneath that is the asthenosphere, and unlike the lithosphere and crust above it, the asthenosphere has a little bit of ductility to it. It isn't going to be rigid like the crust is. Rocks aren't quite fully liquid at this depth, but are able to flow a little bit. There is some movement. And then below the asthenosphere, we get to the mantle. The mantle's huge. It's almost 3,000 kilometers thick. Big chunk, majority of the Earth's interior is the mantle. And below the mantle is the outer core, and that is thought to be fully liquid, or mostly liquid, made up of different kinds of metals. Probably a mixture of an iron and sulfur combination. And then lastly, we have the interior of the Earth, the inner core, which is thought to be solid, a solid ball of metal composed of mostly iron and nickel all stuffed together in there. The topic of our study occurs at the very bottom of the mantle, right kind of before you reach that boundary between the liquid outer core and the mantle itself. This lower section of the Earth's mantle is what's thought of as a subduction graveyard, where large pieces of oceanic crust get subducted back into the interior of the Earth, sink to the very bottom of the mantle, and get reheated by the outer liquid core. And the study that we're looking at has actually proposes a different theory. Before we can really jump in there, we we have to better understand how the heck scientists are getting any information from the bottom of the mantle at all, because it's like really, really far down. Knowing what's going on at the bottom of the mantle is like being able to read a newspaper in Florida when you live in Maine. It's that crazy, and it's approximately the same distance. It's a bad analogy, but who cares? And there are two ways that scientists can kind of understand what the mantle and core, deep parts of our Earth look like. First of those is through earthquakes. That's right, because when an earthquake happens, it propagates seismic waves. The shaking, the actual physical shaking of an earthquake shakes the entire planet a little bit. And based off of extremely sensitive instruments, geophysicists can measure those waves as they propagate through the Earth. As seismic waves pass through very dense material like solid rock, it moves quickly. But when it reaches softer types of solids or even liquids, those waves either slow down or completely fail to propagate entirely. This is how we know that the outer core of the Earth is liquid in the first place, because there are waves that either completely slow down when they reach that liquid part of the outer core, or they completely disappear because they can't travel through liquids. And so, using the seismic information, scientists know about these large, dense bodies in the bottom of the mantle. The next part of the puzzle, though, has to do with what these pieces of rock are actually made of. And most of that information has been found in ocean island basalts, what are known as OIBs, OIBs for short. The OIBs tell us all kinds of amazing information about deep mantle processes, because little glips and gloops and globs of this stuff end up coming up to the surface in hotspots, which are thought to be the most direct path from the deep mantle. And there's a proof for it as well, because a major part of the study is based off of helium isotope concentrations. The older a rock body is, the more helium isotopes it's going to have. A specific helium isotope, what was the specific helium isotope? I believe it's helium-3. That's what they're referring to. Yes. The helium-3 isotope is known as a very old isotope because it was around from the start of the universe itself, from the Big Bang. So the more helium isotope in a substance, the older that substance is. And based off of studying ocean island basalts, we can find ocean island basalts that have very high ratings in the helium-3, which means that it's very old stuff coming from these ocean island basalts. And they kind of trace that helium-3, those magmas high in that rich old helium goodness, to the lower mantle, to those dense parts of rocks that they used from those seismic waves. And that's what the basis of this study is using to determine that these large pieces of rock in the lower mantle are from these ancient rocks that have been around since the formation of the Earth itself, which is absolutely wild and totally fascinating. But now, to kind of circle back around to the original article that we were looking at in the first place, the original news article, where it's stating that mysterious underground continents may be as old as Earth, and it's not totally incorrect. I think, yeah. The thing is that so far as I can tell, the original article for which the news story was based off of never actually refers to these dense masses in the deep mantle as continents. They're just continent sized. And so the news story here is kind of sensationalizing things a little bit by saying that they're underground continents. It sounds like that there's mole people living on the bottom of the mantle or something, and it's not quite the case. I can understand why they did it, though. It helps to kind of picture these things as being continents, because these large masses in the bottom of the mantle are, for functional reasons, as large as continents. They are massive, absolutely huge. and as the study may have indicated, may be as old as the Earth itself. So all in all, not too bad a twist there by this article, but not entirely truthful to the direct science as it was. I don't know. In terms of how badly different articles can twist things, it can get a lot worse than this. So I'd give this maybe a 6.5 or a 7 out of 10 in terms of maximum truthiness in terms of its depiction on there. Very cool. I have a link to both the news article as well as the original abstract for the research down below, as well as some other sources that kind of go over the research as well in a bit of a more digestible manner to kind of help you understand a little bit of the differences there. Super interesting and super fascinating. I really think that geophysics, in terms of determining what's down there, what's really down in the earth, is so cool because it's such a mystery. And sometimes we can get little pieces of mantle that come up in volcanoes, but a lot of the times scientists have to be real sleuths here and really sleuthing things out by literally sniffing the helium that formed when the universe cooled after the Big Bang. It's just absolutely crazy that we can do that and find out information about the mantle. It is so cool. Hope you enjoyed this little foray video into the cutting edge of geophysics and science. I plan on doing a lot more of them because I just think it's really cool stuff, really cool to see what the latest science is all about and share it with you, and also see kind of how maybe the media has been twisting things a little bit as well. Keep them honest and make sure to stay clear from that fake news, rock stars. Get out there, have some fun, rock around, and we'll catch you next time, rock stars. If you like this video, you'd like to see more, feel free to let me know in the comments below. And if you have any recommendations on cool articles that you read that you'd like to see picked apart, feel free to drop them in the comments as well. It's been awesome making this video for you. Until next time, keep on rocking.